In this demo, we are going to walk you through the typical development lifecycle using DX@Scale. As a developer, the first thing that I'm going to do is head over to the project board and see if there are any tasks that I can pick up. As we can see here, there's one task in the to-do column, and it's a fairly simple one. We just need to add a preferred method of contact to a case. Switching over to VS Code, the first thing that I'm going to do is check out a feature branch from our main branch where we can make our changes. I'm then going to fetch a scratch.org from a pre-prepared scratch.org pool. A scratch.org pool is a collection of scratch.orgs that have been pre-installed with our managed packages, thus reducing the amount of time we spend preparing scratch.orgs instead of doing actual development. If we head over to installed packages, we can see that our managed packages Salesforce Billing, Salesforce CPQ, and Marketing Cloud have already been installed, and ordinarily this installation would take up to an hour or more. Before we can make our changes in the scratch.org, we need to push our source code to the scratch.org first. Once that's done, we can head over to the scratch.org and make our necessary changes. In this case, we're going to add a custom field to the case object and add the field to a couple of our case layouts. Now that we've made our changes in the scratch.org, we can head back to VS Code where we pull down the changes into source control. As you can see, the changed layouts and the new custom field have been pulled from the org. We then need to move the new custom field from the default directory to the case management package. Lastly, we stage our changes in Git and write a meaningful commit message containing the user story ID and push the changes to GitHub. Now we can raise a pull request against our main branch and initiate the peer review process. As part of the PR process, we run 3 GitHub actions. We validate changed packages, perform static code analysis on Apex classes, and validate the metadata coverage of unlocked packages. In the validation of changed packages job, we are deploying metadata and running Apex tests in a scratch.org that has been fetched from a scratch.org pool. These scratch.orgs have been pre-installed with managed packages as well as our latest package versions, which means that we can go and determine which packages have actually changed in the current PR and only deploy the associated metadata of those packages. And in this way, we significantly reduce our PR validation times, which is important because our developers need quick feedback on their work. In this case, we are only deploying the 2 packages that we modified, which are the source UI and case management packages. Back to our PR, I've received an approval from a reviewer and all of our status checks have passed. So I can go ahead now and merge this PR. Immediately after a PR is merged, a build is automatically triggered where new package versions and their associated SF-PowerScripts artifact are created. The SF-PowerScripts artifact contains additional package metadata that is not supported by Salesforce and enables many of SF-PowerScripts features on the deployment side. The SF-PowerScripts artifacts are published to an artifact registry where they are versioned and stored for future releases. The build command can determine the order in which to build packages based on the dependencies defined in the SFDX project JSON, and will build the packages in parallel to save time. The build command has also been optimized to only build packages that have changed, and it does this by comparing git tags of packages. As you can see, the build has generated the case management and source UI SF-PowerScripts artifacts and published them to our private NPM registry. Now that we have our artifacts, let's go and release them to our environments. Here is an example of a release definition that defines the shape of a release, including information about which artifact versions to deploy, and other release parameters like whether or not to skip the installation of an artifact if it's already been installed in the org. At the workflows, we trigger a new release specifying the file path of the release definition that we just saw. Here we have our linear release train that goes all the way up to prod, and it's waiting for our approval to initiate the deployment to dev. Looking at the logs for the release command, we can see that it started off by fetching the artifacts that we defined in the release definition. It then went and determined that the case management, source UI, and source M specific alias post packages needed to be deployed. The release command generates a changelog in Markdown format that gets saved to the repository. It provides an at-a-glance view of all your environments and precisely which release they are currently on. There is also a full breakdown of all the artifacts, work items, and commits that have gone into each release, providing full traceability. Click on work items to redirect directly to the user story. SF-PowerScripts can collect metrics on packaging and deployments. These metrics can be used to build beautiful dashboards on a platform of your choice. Here we have an example of a dashboard that was created using metrics collected by SF-PowerScripts. It shows various information about the production environment, including the packages and the time they took to install in the production environment, the average time it takes to deploy to production, and the total number of deployments to production per week. The end-to-end process that you have just seen in this demo, from raising a pull request to get your changes validated, all the way up to deploying your packages to an org, is enabled by the SF-PowerScripts orchestrator commands. The prepare command creates a collection of scratch orgs with our managed packages and source code installed. The validate command then consumes one of these scratch orgs to validate metadata in an incoming PR. The build command then creates package versions and their associated SF-PowerScripts artifacts, which can then be published to an NPM private registry. From there, the artifacts can be released to our upper environments using the release command. Together, these commands help simplify the package-based development workflow, allowing you to spend less time on creating and maintaining pipelines and more time on what matters most, development. I'd like to finish off by thanking the open source community for their continued interest and contributions to the DX at Scale toolset. Thank you.